Hello again. In this video, we're going to look at incorporating polyatomic ions into our ionic compounds. So, polyatomic ions are a group of covalently bonded atoms that acts as an ion. So these are going to participate in ionic bonding. And in the last video, recall that usually ionic bonding is between a metal and a nonmetal. But sometimes these polys can take the place of either the metal or the nonmetal, depending on the charge of the poly. So here is a table of some of the common polyatomic ions. So ammonium is going to be a common positive polyatomic ion that we'll look at, and then the other ones we'll use are going to have negative charges. Okay, so when you are writing ionic formulas with the addition of, so like now we're adding in polyatomic ions, you're still going to write each ion, and you're going to still put the cation first, so the ion that has the positive charge. Your overall charge still has to equal 0, so we'll either the charges are going to cancel, and we just write the symbols, or if the charges aren't canceling, we'll crisscross the charges to find the subscripts. And if we are crossing over some number, like that's not 1, we will use parentheses around the polyatomic ion. And we'll look at some examples with that. So brome numerals are still going to be needed for transition metals. And if the subscripts can be reduced, you still want to reduce them. Okay, so here's some examples. So this first one we have, again, is potassium chloride. This was one that was featured in the last video. But here, this IDE tells us, so IDE tells us we have a monatomic ion, except for the case with hydroxide. That one does in an IDE, but hydroxide is a poly. So besides hydroxide, if we have the second one, the second ion, if it's ending in "ide", then that tells us it's a monatomic anion. So here, potassium chloride, this "ide" means we're just looking at chlorine and not some kind of poly that has chlorine in it. So how do we know it's ionic compound first? Potassium is a metal, and chlorine is a nonmetal, therefore ionic. So we have potassium, it's K, it's in group 1, so if it was an ion, it would have a positive charge. Chloride, so chlorine, is Cl, it's in the halogen, so it would get a negative charge. And then there we would cancel those charges, so that would give us KCl. All right, so let's look at magnesium nitrate. So magnesium nitrate, first off, how do we know it's an ionic compound? So magnesium is a metal, and this time, see how nitrate, we have ATE and not IDE. This tells us now we have some kind of polyatomic ion here. So magnesium is a metal, nitrate is a poly, so this still tells us we have an ionic compound because our polys here are they do participate in ionic compound. It just so happens that nitrate is taking the place of the non-metal position. So magnesium is Mg. It's in group 2, so it gets a 2+ charge. Nitrate has the symbol NO3, and it has a minus charge. Now, if you're curious about where I got this symbol and this charge, there's often most Google searches can give you like tables of common polys. Some of them, like the more common ones, it wouldn't be a bad idea to know them. Or if you still have that reference sheet I gave you back in January. On the back side of that reference sheet, so the front side has the periodic table, on the back side there should be at the bottom of it like a table of common ions, and you should see some of these common polyatomic ions on there, like their names and their symbol and charge. So we have Mg2 plus and NO3 minus. From there, do we crisscross or cancel? A 2 plus and a 1 minus don't cancel, so we have to crisscross them. Now, when we're crisscrossing these, we're crossing over some number that is not 1 to the poly. So we don't want this to read as NO32, like NO32, I mean. We want it to read as parentheses NO3 close parentheses 2, like there's 2 NO3s and not NO32. So here's where I was talking about if more than one polyatomic ion is needed, you need to put parentheses around the poly. So we have Mg. This understood 1 gets crossed over. So Mg1. And then this 2 gets crossed over. But we have to put parentheses around the poly. So we have NO3, that's nitrate. And there's 2 of those. All right, so then this next example here, copper 2 chloride. So how do we know it's an ionic compound? Well, copper is a metal. Chloride, IDE, tells us that's chlorine. So chlorine is a nonmetal, so metal non, that means ionic. Copper is Cu. This Roman numeral right here, since copper is in the transitions, this Roman numeral tells us its charge here, so it's a 2 plus. Chloride, again, ide means monatomic ion, so just one type of ion here, or one type of atom, I mean. So we have just chlorine. Chlorine, we know, gets this negative charge. So we have a 2 plus and a 1 minus. Those do not cancel, so we crisscross. And that gives us CuCl2. All right, let's look at some more. So here we have calcium oxide. How do we know it's ionic? Calcium's a metal. Oxide, again, IDE tells us that it's a monatomic ion, one type of atom, which is oxygen. So calcium's a metal, oxygen is a nonmetal. So calcium is Ca. It has a 2 plus charge. Oxide, so oxygen is O. It has a 2 minus charge. Crisscross or cancel. We would cancel those to get CaO. All right, this next one here, aluminum chlorate. So how do we know this is ionic? Aluminum is a metal. Chlorate, so here now again we have this 8 term. 8 tells us it's a poly. So we have a metal with a poly, that tells us it's ionic. So aluminum is Al. It has a 3 plus charge. Chlorate, again, this 8 means it's a poly, not just chlorine. So you would need to check the polyatomic ion table. And we have that chlorate is ClO3, and it has a negative charge. So here, crisscross or cancel. They do not cancel, so we have to crisscross. But again, we're crossing over here a number other than 1 to this poly. So since that 3 is crossed over, we're going to want to put parentheses around our poly. And then this understood 1 is crossed over with aluminum. So we have Al, understood 1, and then parentheses ClO3, close parentheses 3. Okay, and you wouldn't want to reduce these 3's here because the reduce rule would be when both of your ions their subscripts can be reduced. So aluminum doesn't have a subscript here that we're going to reduce by 3. So we have Al, ClO, 3, 3. All right, and then this next one here, we have iron 3 oxide. So we know it's a ionic compound because iron's a metal. Oxide, IDE, tells us it's one type of atom. So oxygen, so iron, or oxygen, sorry, is a nonmetal. So metal non, therefore ionic. So iron is Fe. This 3 here tells us its charge is 3 plus. Since it is a transition, we would need those Roman numerals. Oxide tells us IDE is oxygen, so O2 minus. Crisscross or cancel. We need to crisscross, so we have Fe2O3. All right, and let's look at another example here. All right, let's say we're looking at ammonium nitrate. So first, how do we know this is an ionic compound? So we have ammonium, and ammonium is a polyatomic ion. So we have a polyatomic ion, nitrite, ITE. Don't get this confused with IDE. So ITE tells us we're looking at a poly here. So polyatomic ion with a polyatomic ion, this is telling us we have an ionic compound here. So ammonium, if we checked our poly table, we would have NH4 is its symbol, and it has a positive charge, a 1 plus. And then nitrite, again, ITE tells us poly. IDE tells us monatomic ion. So nitrite, if we checked our poly table, is NO2 with a negative charge. So here, when we crisscross or cancel, we have a 1 plus and a 1 minus, so those are going to cancel. So we're going to push these symbols together, and so that gives us NH4 NO2. Okay. All right, so that's writing the formulas, and let's go the other way and write the names. So for the names, you would write the names of both the ions, still putting the cation first. If the anion is monatomic, you are going to change the ending to "ide." If it's polyatomic, you're going to just leave it however it's called. For our ions with variable oxidation numbers, so those transition metals, we're going to write the oxidation number in parentheses using Roman numerals, and our overall charge still needs to be 0. All right, so let's look at some examples here. All right, this first one, we have NaBr. How do we know it's ionic? Na, we know, is sodium, and sodium is a metal. Br is bromine, which is a nonmetal. So metal, nonmetal, therefore it's ionic. So naming this cation, we have sodium. Is sodium a transition metal? It's not, so we don't need Roman numerals. So we move right on to our anion. Is our anion monatomic, as in one type of atom, or is it polyatomic, as in more than one type of atom? It's monatomic because it's just Br. So we change the ending to "ide." So this is going to be sodium bromide. Okay. Our next example here Na2CO3. How do we know it's ionic? Well, we have sodium, Na, which is a metal, and it's with CO3, this is a polyatomic ion here. So we have metal with a poly, that means it's ionic. So sodium, and again, sodium is not a transition metal, so we don't need those Roman numerals. So moving right on to our anion, we have CO3. We have here more than one type of atom. We have carbon and oxygen, so therefore that means this is a polyatomic ion here. So CO3, if we were to check the poly chart on the backs of our reference sheets, we would see that CO3 with a 2- charge is what we call carbonate. So we are not going to change the ending of that name, we're just going to leave it carbonate. You change the ending for our monatomic ions here. Alright, so this third example, FeCl3. How do we know it's ionic? Fe is a metal. Cl, we have one type of atom, so monatomic ion here. That's chlorine. So metal, and then chlorine's a nonmetal, therefore ionic. So we have iron for Fe. Is iron a transition? Yes. So let's leave parentheses for its oxidation number. And then we have Cl. Is that monatomic or polyatomic? It's monatomic because it's one type of atom here. So we change the ending to "ide." So we have chloride. All right, iron, something chloride. We have to go back and now find what iron's oxidation number was here. So again, we want to split up those ions and then uncross your subscripts. So that leaves iron with this 3, and there's an understood 1 here. So that leaves chlorine with a negative, and then check the anion. Does chlorine have a negative charge? It does, so that means iron has a charge of 3+ here. All right, and let's look at another example up here. All right, so first off, how do we know this is ionic? Well, we have this group here of atoms acting as one ion here. So NH4 is ammonium, which is a polyatomic ion. Sorry, NH4 plus is ammonium, which is a polyatomic ion. And this other kind of set here, SO4 with a 2- charge, is sulfate. So we have a poly and a poly, therefore we have an ionic. Ammonium is going to be the only positive polyatomic ion that we'll look at here in these videos. So that means keep an eye out on it because it's the one that can replace the metals. Okay. All right. So most of our other polys though that we look at are going to have a negative charge. So generally they are taking the place of the nonmetal. But keep an eye out for ammonium, which can take the place of the metal since it's positive. All right, so NH4 again is ammonium. It's not a transition metal, it's a polyatomic ion, so we do not need the Roman numerals. And then moving on over to the next one, we have SO4. And if you were to check your reference sheet, you would see that SO4 with that 2- charge was called sulfate. So SO4 is sulfate. We are not going to change the ending of this because it's a polyatomic ion and not a monatomic ion. So we have ammonium sulfate. All right, so that is all for this video.